So we're going to start today's lesson with a warm-up, but it's quite a lengthy warm-up. It's kind of a mini lesson disguised as a warm-up. It's called assumptions, what we can assume and what we cannot assume about a diagram. And if you know what to assume and not assume, it's going to save you a lot of missed points throughout the whole year in geometry. I want you to take a minute and read what you may assume from a diagram. So I want you to take a minute and read this to yourself. What you may assume. Go ahead. So to me, the may assume column is kind of like, that's just common sense. Like, the may assume column is not very enlightening to me. I mean, it says things like, you may assume that lines that look straight are straight. You're like, well, duh, I assumed that anyways. You can assume that if points look like they're on the line, they're on the line. You can assume that if two lines look like they cross, well, then they really cross. That kind of thing. Relative location means if a point looks like it's inside a shape, it really is inside the shape. You're like, oh my gosh, these things are like so self-explanatory. My favorite one is the last one. You can assume that the figure exists. It's not a figment of your imagination. It's actually there in real life. That's deep thinking, isn't it? Okay, now I want you to read what you may not assume, which is so much more important. Read what you may not assume, paying really close attention. Go. Okay, I'm not going to point any of these out because they're all equally important. When we do the warm-up in just a minute, each time we check may not assume, it's going to be because of one of these reasons on here. So let's dive right into the warm-up because this is really going to teach us what we can assume and what we can't assume. Pay really close attention to what we can't assume, okay? So let's look at this. I'm going to give you a figure. It's kind of a crazy figure. I just made it up myself. So that's the figure, and I want you to use your page and decide what you can assume and not assume from that figure. We're going to do it together, because we don't have time for you to do it on your own and then come back and do it together. Oh, undo. Okay. The first one says, the figure formed by connecting points A, B, and C is a triangle. Can we assume that that figure is a triangle? Not a special triangle, but just that it's a triangle. Yeah. We can assume that if those points look like they're on the segments, they're on the segments. And if they look like they intersect, they intersect. So that's a really basic one. That one's a check. We can assume. Yep, we can assume. Next one. GH is perpendicular to CD. And I will tell you right now that this statement is the one that gets the most kids in trouble the most times in geometry. Now, they totally look like they're perpendicular. That totally looks like a 90-degree angle. I know it does. I agree with you that it looks 90. But since there's no markings, there's no box, no one told us it equaled 90, no one told us they were perpendicular, even though they so look perpendicular, you cannot assume. And I can't tell you how many times in the angles unit you're going to see lines that look like this, and you're going to put a 90-degree on there. You're just going to assume they're perpendicular without me telling you. And that is going to get you the problem wrong. Okay? So I put a star by that one. Next one says, AD and GH, and GH intersect at point J. Oh, I skipped one, guys. I'm sorry. We can assume things intersect. That's on the part of what we can assume. I totally skipped one. Let's go back. Segment AB is congruent to segment BC. Segment AB is congruent to segment BC. Do they look congruent? Maybe, kinda, sorta. Is there anything that confirms that they're congruent? No. And what's the top thing of what you cannot assume? Congruence. Don't ever assume that two things are congruent unless someone tells you. So that is a big no-no. Do not assume, do not assume, do not assume. Okay, the next one. This quadrilateral right here is a square. GKDJ is a square. What would have to be true to assume it's a square? The angles would have to be 90, and all the sides would have to be equal. Do we have enough information to assume that? Does it look like a square? Absolutely. Could it be a square? Maybe. But we would have to have more information. We would have to have a ruler. We'd have to have a protractor. You can't assume, even though it looks like a square, that's not a square. Innocent until proven guilty, right? J is the midpoint of GH. Look at your list. Are we ever allowed to assume midpoint? Never, no, don't do it. Can't assume that something's in the middle. Can you assume that it's collinear with those points? Yeah, it's collinear, but don't you dare assume it's right smack in the middle. It might not be right in the middle. Point E is inside this triangle, and F is outside the triangle. Okay, E is inside the triangle, and F is outside the triangle. That one's common sense. That one you're allowed to assume. If it looks like it's inside, it's inside. If it looks like it's outside, it's outside. That one's easy. Ooh, GH is parallel to ID. GH, this red one, is parallel to ID. What do you think? This one is so tempting. And, you know, I don't see the word parallel lines on what I can't assume. But what do you see instead? Good! Y'all are so smart. You can't assume non-intersecting lines, which is parallel and skew. You can't assume. So even though those pink segments, they sure do look parallel, but there's no arrows in the middle of, or on the line. There's no symbol, and so I'm sorry, but we're not really sure if they're parallel, even though they look parallel. Okay? AJ is greater than JD. I think when I erase this, my dots are going to go away, so sorry about my dots going away. AJ, so from A to J, is greater than J to D. Have you ever solved a problem in this class and you plug the numbers back in and you're like, wait, those don't really fit with this diagram. That diagram was not drawn to scale. Well, that's our right. We're allowed to not draw diagrams to scale. So even though AJ looks greater than JD, without any numbers, without numerical evidence, we cannot assume that it really is bigger. We don't know the actual length of those lines. Even though our eyeballs tell us it looks bigger, we have not confirmed it. So you can't assume. Now, I am going to tell you that this next one you can assume. And you're like, oh, Miss Tanton, those are like the same sentence. They both have a greater than sign. Why am I allowed to assume this one but not the other one? Y'all know? This one says, if you can't read that if you're watching the lesson, AJ is greater than AC. I'm saying you can assume it. Why in the world would you be allowed to assume that one? Here's AJ, and here's AC. The difference is that these are overlapping, right? AC is part of AJ. A part is always less than a whole, okay? So because these are overlapping, because C is in between A and J, that changes things, and that's why we're allowed to assume it. All right, we're almost done. A, C, J, and D, A, C, J, are collinear. You're allowed to assume collinearity. That's just on your list of allowed to assumes. Point K is between I and D. To be between doesn't mean it's in the middle. It just means they're collinear, and we're allowed to assume collinear. So that is the answer to the warm-up, assumptions from a diagram.